Okay, how to do a linear differential equation in the easiest way possible. First step is we're going to make the differential equation look like this. So dy over dx plus cosine x over sine x times y is equal to x sine x over sine x. All we did was divide by sine x. So we obtain dy over dx plus cosine x sine x times y is equal to x. Okay, that's step one. Step two is we're going to use this formula to find some function that we can multiply by this linear differential equation so that we could do the reverse product rule. This is the product rule, and we're going to do the reverse product rule. Normally we go this way. We take the derivative of two functions, multiply them by each other, and we obtain f prime g plus g prime f. But we're going to try to manipulate this differential equation to be the left side so that we can simplify it to the right side. So mu is equal to e. P of x is cosine x over sine x, cosine x over sine x dx. So e to the, if you let u equal sine x, du is equal to cosine x dx, then you're going to be left with 1 over u dx, du, and then we're going to be integrating that. Ln u is equal to ln sine x. So e to the ln sine x, e to the ln and the e cancel, and we're left with mu is equal to sine x. Okay. So we're going to multiply the whole equation by mu. So sine x dy over dx plus sine x cosine x over sine x times y is equal to sine x times x. This should be f prime, or let's do this in green so you can see where it's coming from. If this is f, let's see what's going on here. If this is f prime, then this must be f. And if this is f prime, then this must be g. So this whole thing must be g prime. And let's check. The derivative. So the derivative of sine x, which is this, must be equal to these cancel, and this is cosine x, and it turns out that this is correct. So we can use this formula right here. This is equal to that. So that must mean that sine x dx, dy over dx, plus sine x cosine x over sine x times y must be equal to just simply d over dx sine x times y. And on the other side, you just simply have x sine x. That's the reverse product rule. Let's put this cut. Let's put this over here so it looks cleaner. So this is equal to that. Now if we integrate both sides with respect to x, we obtain this will cancel with this dx. This will cancel with the differential operator, and we're just left with y sine x is equal to the integral x sine x dx. Now if you use the tabular method, we're gonna take the derivative of x and we're gonna integrate sine x dx. So the derivative of x is 1, derivative of 1 is 0. This is going to be plus, minus, plus. This is cosine x, but that's going to be negative, because the derivative of cosine x is negative sine. So negative cosine x, taking the derivative, will be sine x. And the integral of cosine x will be negative sine x, so this will be positive sine x. We're going to go diagonal. Notice that this is ignored. Ignore that. And if we take another integral sine x negative cosine x, this is 0. So we are left with y sine x is equal to negative x cosine x minus sine x plus c. To QC check this, we could just let u equal x, dv equal sine x dx, du is equal to dx, and v is equal to negative cosine x. We cross these things together, get negative x cosine x minus the integral of negative cosine x dx, and we're left with negative x cosine x plus sine x plus c. So that means that this must be a negative. The integral of cosine x is sine x, and you keep the negative there. So this is a good way to check your tabular method. I don't really like to use tabular method because of these simple mistakes right here. But notice that we have the c here. This c is very important. We're going to keep it there when we divide by sine x. sine x. So y is equal to negative x. Cosine x over sine x is cotangent x. And then sine x over sine x is plus 1. And we're going to have a constant over sine x. But actually, let's erase this. Because simplifying when you're doing differential linear equations sometimes makes things more complicated than they need to be. Because we have an initial value problem here where when x is pi over 2, y is 2. So we're going to use that. This is 2. When x is pi over 2, cosine pi over 2 plus sine pi over 2 plus c, all divided by sine of pi over 2. Cosine of pi over 2, 0. This is 1. And this is 1. So what are we left with? 2 is equal to 1 plus c. So therefore c must be equal to 1. Going back to this equation, we're left with y is equal to negative x cosine x plus sine x plus 1 all over sine x. And this is the solution to the linear differential equation that we were originally trying to solve. I hope that was helpful.